A game board consists of 64 squares that alternate in color between black and white. The figure below shows square P in the bottom row and square Q in the top row. A marker is placed at P. A step consists of moving the marker onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? So here I have a checkerboard, and this is P, and this is Q. So now let's say we start from P and go left and up and go to this point. Then we take another left and up and go to this point, and this point, then this point, and then let's say we turn from here to the right. Then we go here, we go here, we go here. So now we're not at Q, but now this has already taken up 7 steps. So this is not a valid path. So that means that we can't cross this point here. So we have to turn from this point right here. So just get rid of this. And now if we turn from the point here and go here, and here, and here, and then we can get to Q in 1, 2, 3, 4, 5, 6, 7 steps. So now another path would be, we take, instead of going left from P, we go right from P here. Then we take another right, we take a left, then we take a right, then a left, then a right, and that's 7 steps to Q. We could also take a right from P and then take a left from there, then take another left and a right, and then a right, a left, and a right. Or instead, from this point, we could take a right and then a left. So this is going to take too long. So there's a better way to do this. So if I mark out P and then Q, I'm just going to label all these squares and I'll be right back. Okay, now I've labeled all the squares. So now what we do is we find out the paths to each square, each white square. So before, we already decided that you can't go past like this point over here. You can't cross over here. So what we're going to do is to A, how many paths are there from P? There is one path from P to A. So that's all you can do. And then to B, there's one path. Same with E. You can only go from P to B to E to get to E. And then to get to C, you can only go from P to A to C. To get to F, it's the same thing. There's only one path. So now, D. So for D, if I write down D here, you can go from P to A and then to D. So P to A and then to D. Or you could go from P to B and then to D. So if you look here, so there, I can write down 2 here. So if you look, to get to A, there's one path, and then you can go to D. And then to get to B, there's another one path to go to D. So to go to D, you have to go to A and then to D, or you can go to B and then to D. So that means that 1 plus 1, so the paths to go to A plus the paths to go to B, should be equal to the paths to go to D. So if we apply that to G, 1 path to go to C, 2 to go to D, so then you would have 3 paths to go to G. And we can prove this by doing the brute force. So to go to G, you can go to P, A, C, and then G, or you could go to P, B, D, and then G, or you could also go to P, and then A, and then D, and then G. So that means there are 3 paths to go to G in. So this works. Now we can do that for all of them. So to get to I, you have to go to F and then I, or G and then I. So F is 1 and then G is 3. So you add them, you get 4. Now H. D is 2, E is 1. So you add them, you get 3. For J, you have to go to G and then J, H and then J. So 3 plus 3 is 6. For K, you have to go to H and then K. So there's no other way you can go to K. So just go from H to K. So that would be 3. And now if you do this for all of them, you will eventually get to Q. So I'm just going to quickly do that. 6 plus 3, 9 for M. And then 4 plus 6, 10 for L. And 10 and 9, 19 for N. And then M to O, that's the same. So 9. And then Q, finally, 19 plus 9 is 28. So your answer is 28.